All right, this is 8.3 in Advanced Algebra 2. Today we talk about hyperbolas and inverse squared. I got to give Mr. Leo his due. You know, he had some great jokes for you. First, this equation right here is really for when two people go bowling right here. Like what would this make? Two people go bowling. That'd be a parabola or a parabola, you know. This is when one person is bowling and they've had way too many energy drinks right there. They're a hyperbola. It's a hyperbola. That's Mr. Leo's humor for you right there. Ba-boom. Hyperbola. You don't even get it, do you? It's just horrible. Yes, that's right. Parabolas or a hyperbola. Way to go, Mr. Leo. All right. The parent function for this looks like this. F of x equals 1 over x, or you can replace the f of x with 1 over x. Let's realize what the heck happens here, okay? So let's realize that, first of all, there's something dangerous right here. What is very, very dangerous about this function? There's a variable in the denominator. We know that you can't have 0 in the denominator, correct? So would you realize that x can't be 0 in this situation, right? So we already know when it comes to our domain that it's like all reals except for x's, or you could say from negative infinity to 0, not included, union 0 to infinity. Isn't that the domain? Like x just can't be 0. You with me on that? X can't be 0. The question is, what about the old range, right? Well, I got a table of values here which you don't have to make. Let's just kind of figure some stuff out. If I put a negative 2 in for x, what would y turn out to be? Negative 1. Let's put 1 over negative 2 to make it more over negative 2, correct? If I put a negative 1 in there, what would y turn out to be? Negative 1 over 1, which is plain old negative 1. If I put 0 in for x, correct? Then you get 1 over 0, which can't happen. Is that cool with you? Can't happen. What if you put 1 in for x? What would y turn out to be? 1. If you put 2 in for x? 1 over 2, correct? And what if you put 3 in for x? 1 over 3. So let's kind of figure this out a little bit here. We know that our domain, right here, our x's, you can't have 0 in there. We've already figured that out. But what can't y turn out to be? Well, if you can put anything but 0 in for x, correct? There's only 3 kinds of numbers. There's a negative, there's 0, and there's a positive kind of number, correct? What if you put any kind of negative number in for x? What would y turn out to be, my friends? Wouldn't it turn out to be a negative number, correct? If you put a negative number in for x, wouldn't y, or your range, if you will, turn out to be a negative number? What if you put a positive number in for x? What would y turn out to be? Some sort of positive number, correct? And you know we can't put 0 in for x, so here's what we've just determined. That y can only be a negative number or a positive number. It is like impossible for y to turn out to be 0, because 1 divided by a negative will become negative, 1 divided by a positive will come out positive, and you can't put 0 in there because it's impossible to put in for x in the first place. So when it comes to your range, would you agree that everything works except for 0 also? You with me on that? Like the y's will never ever turn out to be 0 in this hyperbola right here. So that brings us into what the asymptotes and the symmetry is. The first thing I want to show you, though, is the symmetry. Look at this. You see how this thing right here and this guy, green, are exactly the same on, like, if they reflect over that line right there, and like this little guy and that little guy. You see how that's like a line of symmetry right there? Cuts it into 2 equal pieces. That's the line y equals x, right? It goes through 0, 0, slope of 1, y equals x. Also, y equals negative x is a symmetry line for that thing. You see how everything on this side is exactly the same as everything on that side. That's y equals negative x. Symmetry involved with it. Intercepts. Where does this thing cross the x-axis and y-axis? It won't. Why not? Because you can't let this thing be 0 in the first place. Those are what's called asymptotes right here. And that's why I gave you a straight edge, because we're going to draw all these asymptotes in. You don't have to draw for this one. Let's wait till the next problem. You see this guy right here? What kind of line is it? Horizontal, vertical, or oblique? It's a vertical asymptote, and it says that this actual vertical line's equation is x equals 0. And you see how this thing will get closer and closer and closer and closer to 0, but never ever touch it. We've talked about asymptotes in here before, have we, or have we not? Where I kept getting closer and closer to the wall, but I will never actually get to the wall. This thing will get closer and closer and closer to 0, but it will never ever ever touch it. It also has a horizontal asymptote at y equals 0. That thing's going to get closer and closer and closer and closer to y equals 0, but never ever touch it. Like I said, y can and x can't be 0 in the first place, correct? That's why you got an asymptote at x equals 0, because that can't happen, and you got an asymptote at y equals 0, because that can't happen. Everything else can happen. So let's dive into this thing. Purple note card coming right back at you. You don't need it out. We got that thing memorized. We're only doing the first basically 3 steps, and honestly, I really care about the first 2 steps. What's the first step on the purple note card every single time? Will it reflect over the old x-axis? Well, here's our new function, correct? F of x equals a over x minus h plus k. The a value is this dude right here, dude in the numerator. You see how this is still a hyperbola right here because you've got the x in the denominator. It is a hyperbola. Cool? If a is negative, that thing will reflect over the x-axis. If a is positive, it will not. You all down with looking at that, our a value. So when we're purple note carding these things, we just want to know, will it reflect over the x-axis or not? We're looking right here. All down with that? Translation, same concept. It's about the h comma k. Whatever they do to this, isn't that a minus h right here? It's just the old opposite of that dude right there. And then the k value, notice it is off out of that term. It is completely separate. It's just something added to it or subtracted to it right there. So this part right here totally tells us where our vertical asymptotes and our horizontal asymptotes are at. That's why we do the purple note card. If you can purple note card this thing, you can figure out where your vertical asymptotes, horizontal asymptotes, then you can make a sketch of that thing really, really, really simply. We don't need a graphing calculator at all. The dilation will happen if this absolute value of a, so who cares if it's negative or positive, we're just thinking it as positive. If that's less than 1, it'll be vertically compressed. If that's greater than 1, it'll be vertically stretched. Okay? And we're not going to mention any of this, just letting you know that that's what happens. It controls the vertical dilation situation. So check this out. First thing we will do, because today we will also talk about inverse squares, is recognize what kind of function this is. See how you got the x down there in the denominator? What is this thing called? So we'll write its name right here, hyperbola. This is a hyperbola. Awesome. Let's do the purple note card. Step 1. Did it get reflected over the x-axis? Yes or no? We're looking right here, correct? That's our a value. It didn't happen, so we'll put ourselves a little dash. Step 2, translation time. K value and h value. We're looking at this first. See, that says plus 2, so what does that really mean happened right there? It moved 2 left, right? It just translated 2 units left. And then when it comes to up or down, we're looking over here. There is no number right there, so what really happened? Put a 0. All good? And that's all I want from you. Even though there is a step 3, this thing did get vertically stretched by a factor of 3. You with me on that? I don't care about that. They ask us to fill out the asymptotes. Our vertical asymptote, it's really, 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 really simple. X, y, x, y. Vertical asymptote will be at x equals negative 2. Now let's realize why. How come? What if x was negative 2? Substitute negative 2 in for x right now. What would that denominator turn out to be? It would turn out to be 0, and that can't happen, right? You can't get 0 in the denominator of a fraction, so that's why the vertical asymptote is at x equals negative 2. It's telling you that that's what x cannot be in the entire domain. With me on that? When it comes to the horizontal asymptote, we're just looking right here, and that would be at y equals whatever this number is, 0. And that means that whatever you put in for x, as long as you're not putting in negative 2, y will never ever turn out to be 0. Sound cool? Let's go to our graph and actually graph those asymptotes. They're kind of done for us. We always graph them as dashed lines because they're not really a part of the graph. So do you see this asymptote right here. Let me get mine ready to go, though. The vertical asymptote right there. I want you to label it like this, VA. Put a colon and tell me where it's at. If you just put -2, that's not good enough. Where is the vertical asymptote at? I need the equation of that vertical asymptote. What is it? X equals -2. And do you see that? Right? You with me on that? And how about my horizontal asymptote? Isn't that at y equals 0? So even though that's the x-axis, and I kind of missed a little bit there, we're going to put it. Go a little bit longer than the x-axis so I can see, make it a dashed line. That's where I said if you wanted to highlight those, you can highlight them. If you wanted to use a pretty pen, you can use a pretty pen, because it's hard to see the asymptotes a lot of times, especially when it's on the x-axis or y-axis. So we'll put HA for horizontal asymptote, and that's at y equals 0. Now before we finish this, look at this hyperbola compared to the parent hyperbola. Basically, besides this dilation of 3, isn't the only thing that happened was that hyperbola shifted 2 units left, correct? Isn't the normal vertical asymptote at x equals 0? See how it just translated 2 units to the left. With me on that? Domain, real easy. What can't x equal? -2 in this situation, correct? So we're going to go from -infinity all the way up to -2. Can it be -2, or does it not -2? Like, does it count or not count? So parenthesis or bracket? Parenthesis. Then what's this thing mean again? The union. We're going to start at -2 again and go all the way up to infinity. Pretty simple. Whatever this x value was, that's the little thing you fill in this spot right here. That's not a highlighter, but that is. That x value basically just goes into that place. Rock and roll? How about the range? Well, same concept. This y value goes into that place also. If you look at your graph, do you see how this thing goes from -infinity all the way up to 0, basically, right? From -infinity to 0. And then since there's an asymptote at 0, you got to unite it, start at 0 again, and then won't it go from 0 all the way up to positive infinity? Remember reading the graph. Range is low to high, and domain is left to right. Cool? So check this, left to right. Doesn't it go from -infinity all the way up to -2? And then you got to start over again from -2 to positive infinity, and then low to high, -infinity to 0. Start over at 0 and go up to positive infinity. Cool? So let's try some more. First, let's realize what it looks like if you reflect a hyperbola over the x-axis. This is your normal hyperbola. You should have been taught a long time ago that the coordinate plane has 4 quadrants. 1, 2, 3, 4. If you can't remember how they go, it's called the coordinate plane. It's like if you make the letter C, 1, 2, 3, 4. Coordinate plane is the letter C, and it goes 1, 2, 3, 4, like that. The normal branches of a hyperbola are in quadrants 1 and 3. You with me on that? If you reflect it over the x-axis, wouldn't this guy come down here and that guy go up there? Correct? So they switch to where the branches, that's what these things are called, just the branches of that thing, go in quadrants 2 and 4. Cool with what it looks like if you reflect it over the x-axis. Okay. What kind of graph is he? That's a hyperbola again. Let's purple note card him. Step 1, did he get reflected over the x-axis? Yes, so we'll write reflect over x. Cool. How do we tell it? See that a value right there? He's negative. All good with that? Translation. Where did he go? 1, 0. Pretty cozy. Vertical asymptote. What variable is involved with a vertical asymptote, x or y? X equals how much? 1. Let's stop one more time. I feel it's kind of my duty to understand why that's a vertical asymptote. Why is x equal 1 a vertical asymptote? What if x was 1? What would happen to that denominator? It would turn out to be 0, and thou shalt not divide by 0. That's why there is an asymptote at that particular place. Horizontal asymptote is located where? Y, not 0, but y equals 0. It's got to be the equation of that line. Graph them both. Realize if they used a scale or not on their grid. And they just went by 1, so label them. And you can see that according to this parent function, number one, the branches are all backwards. How come the branches are in different places? It got reflected over the x-axis. Cool with that? Number two, it translated somewhere. Didn't it move 1 unit right? You with me on that? So that's why this asymptote is over here, not x equals 1. Cool? Domain, from negative infinity, right? That's where this thing's going, from negative infinity all the way up to this asymptote, which is located where? At 1. Then it'll start back over again from 1 to infinity. Range starts all the way down here from negative infinity, will work its way all the way up to y equals 0. And union starts over at 0, goes up to positive infinity. One more of those. Why don't you get it done for me? Name him, purple note card him, and fill it in and graph him. Pause the video, get that done for me, please. Here's what we got. Do you see how it also shifted it up 2 units? Correct? Not only did it translate 1 unit to the left, then it popped it up 2 units. So if normally y can't equal 0, right? If y can't equal 0 normally, but you continue to add 2 to all those results, shouldn't y not be able to equal 2? Because you're taking basically 0 and adding 2 to it and saying that's what you can't be. These were called what? Hyperbolas. Notice the stuff downstairs in the denominator. What power was it all raised to? First power. Next page, inverse square. Inverse square, so similar, yet so different. Basic function, what's different? Of course, there is a variable in the denominator, correct? But what's happening to that variable in the denominator? It's being squared. That's why it's called an inverse squared situation. So, same concept. What can't x equal? X can't equal 0, right? So it doesn't happen because y would turn out to be undefined. Now let's realize what happens when you start putting in all these numbers. What if we put a negative 3 in for x? What's negative 3 squared turn out to be? Positive 9, right? So doesn't that turn out to be 1/9? What about negative 2? What would you put in? What would shoot out of that situation for a y value? 1/4, then 1 over 1, right? If you put a 1 in there, wouldn't you get 1 over 1? If you put a 2 in there, you get 1/4. If you put a 3 in there, you get 1/9. What kind of numbers always popped out of this thing? Positive numbers always popped out. What didn't pop out? 0 definitely didn't shoot out for the y value, correct? And negatives didn't shoot out either because we were square in this situation. Look at the graph. Where is everything located on the old y-axis? What kind of numbers are all of these numbers? Y values. Here's your y values. 1, 2, 3. Aren't they all what kind of numbers? Positive. Do you see how the range is never down here in the negative region for your normal parent guy? So when it comes to symmetry, or let's do this, your domain, sorry, it can be negative. It just can't be 0. You with me on that? You can put anything you want to in for x except for 0. Rock and roll? But when it comes to your range, because of the fact that these numbers that you're putting in are getting squared, they can't come out negative and they can't come out 0. Won't they be 0 or larger in that situation, from 0 to positive infinity? Symmetry, here's some symmetry lines. Isn't the y-axis a line of symmetry for that thing right there? Is everything on the left exactly the same as everything on the right? And that's it. Asymptotes, it's got 2 again. It's got a vertical asymptote here. X can't equal 0. Cool. And we also know that y will never be 0, or it won't even be below that in that situation. When it comes to the purple note card, it is the same thing. It'll reflect over the x-axis if this a value is negative. Your translation, hopefully this is in factored form right here. Do you see how it's x minus h quantity squared in that situation? So it's still whatever they do to it inside the parentheses right there, and your k value and the dilation still works out the same. The only thing you have to recognize now is first, what kind of graph is this? Is this a hyperbola or is that an inverse square? So we will name him. You can abbreviate it inverse square just like that. This is an inverse square situation. Let's purple note card him. Step 1. Did this guy get reflected over the x-axis? Nope. Step 2, translation. Being how it's a nice, neat factored form, that's beautiful for us. It translated where? -2, comma, 0. Everything else is similar. You just got to be careful with your domain and range. Okay? Your vertical asymptote will still be at x equals -2, and your horizontal asymptote will be at y equals 0, whatever those two dudes were in your translation. Awesome. Go graph them for me. Here's the graph of this. All that this junk means down here is that's the window parameters. Your x went from -5 to +5, and your y went from -2 to 8. That's all that this typed out means, is that's like the window from a graphing calculator. So we'll graph our asymptotes at x equals -2 and at y equals 0. Sometimes it looks like it touches it, but it won't. So horizontal asymptote at y equals 0, vertical asymptote at x equals -2. And this is where you want to let the graph kind of help you a little bit with your domain and range. The domain, how far to the left does that thing go? From -infinity all the way up to that asymptote of -2. Then it starts back over again, and we'll go to +infinity. Feel good about that? The range is what changes. This is an inverse square. It limits it. What's the lowest that this thing will actually approach? 0. And it will never actually even get there, so that's why 0 is not included. You go from low to high. The lowest this will go is 0, not inclusive. The highest it will go is to +infinity. So you got to realize on whatever problem it is it a hyperbola or is it an inverse square? What is this first one? What do you got? Hyperbola. So think about the parent function. Where are the branches? You know, are they like all on the top, all on the bottom, over in opposite quadrants? We just got to think of what it looks like. First, let's purple note card, and let's see how easy this would be. Did it get reflected over the x-axis? Nope. Translation. Where did we translate to? Nothing happened to x, right? And then didn't it go up 1 unit? Cool. Now, I guess we can put our asymptotes equations in here. X equals 0 and y equals 1. Graph the asymptotes next. Before you want to do domain and range, graph the asymptotes next. You got a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 1. If you're going by ones, you don't have to label the scale for me. If you're going to change by anything else, you should label both scales. Like if you wanted to count by 2s or something like that, you better put your scale on there. If you put nothing, we'll assume you go by 1s. So that's a horizontal asymptote at y equals 0 and y equals 1, my bad. And a vertical asymptote at x equals 0. Feel good about the asymptotes. Now let's make a sketch before we go. What is this guy? Hyperbola or inverse square? Hyperbola. Did it get reflected over the x-axis? Yes or no? So realize I will cover up those parent functions on the wall come test day so you can't see them. You have to recognize where the branches are normally. Isn't it something like this? Use pencil. Don't use your pen. Okay? All I want you to use pen/highlighter for is asymptotes. There's where the normal hyperbola is. That's our sketch. Okay? That's what we're sketching. How come they're in those branches, 1 and 3, instead of in 2 and 4? Because it did not get reflected over the x-axis. All good with that? Then you can use that to help you fill out your domain and range. To the next guy. Call on some people. Recognize, what is he? Is he hyperbola or an inverse square, Rachel? What do you think? That is correct. He is a hyperbola. The denominator is not getting squared. So write his name. That'll do you more good than you think to keep writing that down. Learning those words helps you on that ACT also. Okay? And then purple note card him. He did get reflected over the x-axis, and it translated 2 units right and 0 units up. So x equals the deuce, y equals the goose. Graph the asymptotes nice and accurately. Let's see, x equals 2. Label the asymptotes.
The tough part is, where do the branches go? How do I make that sketch? So since this is a hyperbola, remember the branches are in like diagonal from each other, right? So normally they are in the odd quadrants, but since this guy has been reflected over the x-axis, they're going to actually be in these dudes. And remember, we'll treat the asymptotes like they are the x-axis and y-axis now, so we're just going to hug these guys. So this is our little nice sketch. So now let's find ourselves a domain. So reading from left to right, if I go way over here at negative infinity, yes, that green thing would totally run into my straight edge. So we're going from negative infinity and touching, all the way to my asymptote. Can't touch a vertical asymptote, so we have a parenthesis. But then we'll start back over again, right over at that vertical asymptote, and go to infinity. That's the domain. We went from left to right. Now let's go low to high. This thing that does go down forever and ever and ever and ever, so it goes down to negative infinity, and it'll go all the way up until it reaches this horizontal asymptote, and it cannot touch it at 0. Bridge the gap with a union. Start over again at 0. That's where this branch will take over and go all the way up to infinity. So cool. Let's keep rolling. Let's see if we can recognize. So here we go. Is this dude, since the x is down in the basement, it's either going to be a hyperbola or an inverse square. See the squared? That's an inverse squared. So we will recognize inverse square, and we'll do the first 2 steps to the purple note card. Step 1, has this guy been reflected over the x-axis? See Mr. Negative there? That's a yes, it has. Then step 2, translated. Opposite game right here, so 3 units to the right, and whatever they add or subtract, it is nothing in this case. So putting the old asymptotes, I get me a vertical asymptote at x equals h, boom, 3, and a horizontal asymptote at y equals k, which is 0. So now I'll take my straight edge and I'll draw those in. Woo, look how fast I could draw those guys in. So don't forget to put the little VA and the HA and their little equation, so need to pause the video real quick to do that. Where, oh, where should the branches be? The inverse square is like the volcano. Remember, this is your normal guy up here where it's kind of like a volcano. Since it's been reflected over the x-axis, it's going to funnel down. So I'll switch to a different color here. It's going to funnel. It starts this way, it goes downward, and then same thing over here. So that's the inverse square. Both branches are on the same side. Normally they're both up, but since this guy's been reflected, they're going down. So let's check our domain out. If I go way over here at negative infinity, would this green branch run into? Yes, of course it would. And if we keep on keeping on, it's going to be touching until we get to that asymptote of 3. Can't touch it, so it's a parenthesis, start back over again, and that branch will again take over at 3, not included, and go to infinity. Nothing changes with the domain compared to inverse squares and hyperbolas. It's just brrr, you got a little critical point at the asymptote. Range, though, is different. Remember, we're going low to high, so down here as low as we could possibly go. Yep. We're touching, negative infinity. And how high does he get? All the way up to 0, not included because you can't touch that asymptote. But notice there's no branch up here, so just one piece to that range. So cool. Let's give you a chance to try some here. So first, recognize. See, x is down in the denominator, so it's either a hyperbola or an inverse square. Check me out. What do you think? Hyperbola or inverse square? This is definitely a hyperbola. So we'll recognize. I want you to spell that word out. Hyperbola. And then we'll do the first 2 steps to the purple note card. 1, 2, buckle your shoe. Has he been reflected over the x-axis? Nope, because that's a positive guy. Translated, opposite game, 5 units to the left and 3 units up. So vertical asymptote at x equals h. Horizontal asymptote at y equals k. Boom. And we'll go draw them in. Watch this speed demon. Woo, that's fast. 5 units left, 3 units up. Why don't you pause again if you need to. And where are the branches? This is a hyperbola, so remember, normally hyperbolas look like this. So since the graph has not been reflected over the x-axis, they're still going to look like that, but just going to hug the asymptotes. So boom and boom, and then I'll let you try the domain and range. Why don't you pause that video and see if you can get the domain and range correct for me. Went from negative infinity all the way over to this vertical asymptote of -5. Can't touch it. Bridge the gap with the union. Start back over at -5 and go to infinity. Then low to high from negative infinity up to the asymptote of 3 and start back over again. So it's for stuff that looks like it's complicated, it just gets easier and easier and easier. Thank you, purple note card. Again, recognize. Hyperbola or inverse square. See the quantity squared? That's an inverse square, baby. 2 steps. Step 1, step 2. Has he been reflected over the x-axis? Nope. Translated, 1 unit to the right, because it's opposite game, 2 units up. Asymptotes, x equals 1, y equals 2 for our vertical and horizontal. Graphing those pups in real quick. Pop, pop, boom. And inverse squares, they're the volcano-looking dude, right? And normally they're both above, so they will stay both above since this guy has not been reflected over the x-axis. Try the domain and range without me and give it a pause. Check it with mine. So there you go. Negative infinity to 1. That's where the asymptote is. And from 1 to infinity, and then as low as this thing gets, see, this is kind of tough for some people. The lowest this thing gets, like we're not touching, the lowest it goes is 2, and it doesn't actually get to 2, not included. So, cool. One more. Give him a try and see if you can do it all without me. Pause the video, recognize, 2-step, put the asymptotes in, find the branches, domain and range. This is a hyperbola. It has been reflected over the x-axis, translated 3 units right, 4 units up. Asymptotes, don't forget the VA and the HA, all that little stuff right here. Where are the branches? Normal or not normal? Not normal, bro. Not normal. And there's your domain and your range, just like it's been. There's like a nice little pattern. So now let's see if you could answer a multiple choice question without ever having to type this in your graphing calculator. Which of these graphs is this dude? Well, I can tell by my little recognition, bro, this is an inverse square. So it is not A, which is a hyperbola. It is not D, which it is a parabola. It's got to be one of these two. Which one's it got to be? Well, it's about where those asymptotes are at. This asymptote would have to be at x equals -2, which is over here, and that's not it. So isn't it got to be this dude right here? Now, if I would have gave you this same question beforehand and didn't let you use the calculator, I'll bet most of us would have said D because we see a squared and we think it's going to be a parabola. That's if it's upstairs, dude. It's going to be a parabola. But that squared stuff is downstairs. That's an inverse square. So cool. Please let us know if you have any questions. Have a great one.